Hello everyone, welcome to my channel Circuitry Simplified by Dr. Shobha Nikam. In this video, I'll talk about sum of product and product of sum forms. But before that, subscribe to my channel, press the bell icon so that you will get notification about my newly uploaded videos. Along with sum of product and product of sum forms, in this video, I'll also talk about standard forms and canonical forms, minterms and max terms. So before you understand sum of product and product of sum forms, you must know what product terms are and what sum terms are. So min terms or product terms, and these are max terms or sum terms. So you need to understand min terms are nothing but product terms and they're represented using small m, whereas max terms are sum terms and they're represented using capital M. Then this is truth table for three variables A, B and C. Here, while writing minterms and maxterms, instead of variables, we use word literals. So here we have three literals A, B and C. Another most important thing is in minterms, 1 is very important. For max terms, 0 is very important. So here, minterms, see binary equivalent of 0 is 0, 0, 0. Decimal equivalent is 0. So for this 0, 0, 0, minterm is M0, max term is capital M0. Here it is M1, M1. So minterms are written as M0, M1, M2, M3, M4, M5 up to M7, and similarly max terms also. So for writing first minterm, if value of my literal is 0, then I'll take complement of that literal. And if value of my literal is 1, I'll take that literal as it is. So here for M0, A is 0, B is also 0, C is also 0. So minterm 0 is A bar, B bar into C bar, and this is product term. Similarly, let's take an example of M3. For M3, A is 0, B is 1 and C is 1. So minterm 3, M3 can be written as A bar, B, C. In case of max terms, as I told you, 0 is very important. So if value of literal is 0, then we'll take that literal as it is. And if value of literal is 1, then we'll take complement of that literal. And here max terms are nothing but sum terms. So my first max term M0 is A is 0, B is 0, C is also 0. So first max term is A plus B plus C. Similarly, same example we'll take M3. For M3, A is 0 but B and C are 1. So what we will write for max term? A as it is, because it is 0. B and C are 1. So we'll take complement of B and complement of C. So it was all about minterms and max terms. While writing equation in sum of product form, what is this? This is sum of product forms. We use minterms because minterms are product terms. So here, see this truth table. It has three literals A, B, C. Output is represented using F, and these are my minterms. So, while writing equation in sum of product form, we must consider minterms for which my output is 1 and discard the minterms for which output is 0. So here in this truth table, also here what is written? F, A, B, C, function ABC. Here this sequence ABC is very important because in examination, truth table won't be given. Only equation will be given. So you need to remember A is MSB. The thing which is written at left hand side or first is MSB and C is LSB, least significant bit. And sum of product form is written as the symbol used is summation of M. For which product terms output is 1? For M1 it is 1, for 2 it is 1, for 6 it is 1 and for M7 it is 1. So here it is written as summation of M 1, 2, 6 and 7. So minterm for 1 is A bar, B bar, C. So it is A bar, B bar, C plus 2 2 is A bar B C. Similarly, 6 is A B C bar and 7 is A B C. So function for this truth table is A bar B bar C plus A bar B C bar plus A B C bar plus ABC, and this form is called as sum of product form. So first thing is, in sum of product form, we consider outputs for which value of output is 1 and we take those minterms and then we add those minterms. Similarly, next form is product of sum. So product of sum means we must consider sum terms and then we will multiply those sum terms. So max terms are nothing but our sum terms. So here for writing equation in product of sum form, we will use max terms. Now in max terms, what is important? 0 is important. So here we will take max terms for which my output is 0. So here for M0 output is 0, for M2 output is 0, for M3 output is 0, for M4 output is 0. So I'll take M0, comma M2, comma M3, comma M4. So here you can see, and in sum of product form we use summation of M symbol. Here we use this pi of M, capital M, 0, 2, 3, 4. Then while writing equation, here again you need to remember sequence. A is MSB and C is LSB. While writing this equation, my first max term is 0 and it is represented as A plus B plus C. So first term is A plus B plus C multiplied by second term is A plus B bar plus C. So here A plus B bar plus C. Similarly for 3, A plus B bar plus C bar, and for 4 it is A bar plus B plus C. So in this way we can write equation in product of sum form. Now we know how to write an equation. From those equations, next step is to implement our circuitry. So what we have in sum of product? We have sum terms, we have product terms. In product of sum also, we have product terms, we have sum terms. So we need AND gates for implementation of product terms and we need OR gates for implementation of sum terms. So if my equation or my function is AB bar plus BCD plus AC, then my first term is product term. So I'll use AND gate. Complement of B is shown by using bubble. Then here second is 3 input AND gate because our second term is B, C, D. And third is AC and then there is addition in between. So here is OR gate. In product of sum, it is exactly opposite. The terms are sum terms. So first we will use OR gate and then there is multiplication. So to implement that multiplication, we will use AND gate. So in this way, from the given minterms and max terms or function, you can implement your circuitry by using AND gates and OR gates. Then key differences between sum of product and product of sum. In sum of product, literals are first multiplied and then added. Name itself indicates sum of what? Product terms. Product of sum is what? It is multiplication of what? Sum terms. So literals are summed first and then multiplied with each other. Minterms or product terms are mainly used in sum of product form, whereas max terms are used in product of sum form. For minterms, 1 is important. So if value is 1, we take that variable as it is. In max terms, 0 is important, or in product of sum form, 0 is important. So for 0, we take literal or variable as it is, and for 1, we take complement of that. Now, next comes canonical forms and standard forms. Here you can see by using this truth table and by using minterms and max terms, we get equation in this form. So this form is called as canonical form. Meaning of canonical form is each and every term consists of each and every literal. So here in first term, you can see A, B, C. All three literals are present. They can be in their true form or in complement form. Here also all are present. Here also ABC all are present. So this form is called as canonical form. Here also, in case of product of sum, all three literals are present in all terms. So they are called as canonical forms, whereas standard form means reduced form. So for reduction, either we can use rules, the binary reduction rules, or we can simply use K-map. So here I'll tell you how to convert canonical form to standard form. Advantage is when we convert our canonical form into standard form, equation gets reduced, and because of reduced equation we need less number of gates. When we need less number of gates, it means complexity reduces, power dissipation reduces, and area on board also reduces, and that is why for implementation we use standard forms. So here, see how to reduce sum of product form. So here, what we can do, we can identify the common terms. So here, in second term and in third term, B C bar is common. So what I can do, I can write first term as it is. Second term B C bar in bracket A bar plus A plus last term. So what is A plus A bar? It is 1. See, if A is 1, A bar is 0. So 1 plus 0, you will get 1. If A is 0, then A bar is 1. Again 0 plus 1 is going to be 1. So this is 1. So here, this form, reduced form, is called as standard form. In standard form, it is not necessary to have all literals in all terms. Similarly, we can reduce this product of sum form to standard form. So our equation is, I have taken same equations, those which were used to represent sum of product and product of sum. So my first term is A plus B plus C. Second is A plus B bar plus C, and then A plus B bar plus C bar, and here A plus A bar plus B plus C. So here you can see in first and in last terms, B plus C is common. And here in two middle terms, A plus B bar is common. So by applying law of distribution, what I can write here, A, B plus C common. So I'll write B plus C as it is plus A into A bar. And here what I can write, A plus B is, B bar is common. So A plus B bar plus C into C bar. So here A plus A into A bar is what? 0. If A is 1 and A bar is 0, then A bar is 0. So 1 into 0 is 0. Or if C is 0, then C bar is 1. So 0 into either of two values are going to be 0. So it is 0. So our equation will get reduced to B plus C into A plus B bar. So by applying different rules or by using K-map, we can reduce canonical form to standard form. Next, see, now how to convert our standard form into canonical form. So here, standard form means all literals are not present in all terms. So here in my first term, here I have taken sum of products example, and here I have taken product of sums example. So my first is A bar B plus AC. So what I'll have to do is, for conversion in examination questions or in gate examination, mostly questions are like the standard forms are given and you need to calculate canonical forms, or canonical forms are given and you need to calculate sum of standard forms, and sum of products are given and product of sums need to be calculated. So here, if my standard form, this is my standard form, so what I'll have to do, I'll have to convert it into canonical. For conversion, I need to identify the missing variable. So here my variables are A, B, C. So A and B are present, but C is missing. So what I'll do? I'll multiply this term with C plus C bar. Value of C plus C bar is 1. Here B is missing, so I'll multiply by B plus B bar. And then what will come? A bar B into C plus A bar B into C bar plus A C B. So A B C and then A B bar C. And this is my canonical form. Now here you can see in every product term all literals are present. Similarly here the conversion of product of sum form into canonical form. So here again you need to identify the missing variable. So here missing variable is C, here missing variable is A. So A plus B bar plus C into C bar, because C is missing. C into C bar is what? 0. So anything plus 0 is that thing. Here I'll add A into A bar. Now by applying distribution law, A plus BC is A plus B into A plus C. So first term plus this first term into first term, that is A plus B bar plus C bar. Similarly here B plus C plus A, and here B plus C plus A bar. So in this way we'll get canonical form from this standard form. So it was all about sum of product and product of sum representation of digital systems. For that, Minterms and Maxterms are important. Understanding of canonical form and standard form and then conversion is also important. So thank you everybody for watching this video. Keep watching and don't forget to like, share and subscribe. Thank you.